Hello and welcome to this video where I will be addressing an issue that is often brought up by flat earthers and geocentrists regarding the rotation of the Earth. This is an argument about airplanes, which it's made quite a lot of times, and I just want to show that it's not accurate. So you probably heard this argument before. Flat earthers and geocentrists will sometimes claim that if the Earth was rotating, say in this direction here, clockwise, that if you were then to fly an airplane, the airplane would travel, it would spend less time traveling against the rotation of the Earth than it would travel with the rotation of the Earth. The reason being that as the airplane travels against the rotation of the Earth will be coming up against the airplane or towards the airplane, and so it will be quicker. Now, the argument then is that this doesn't happen, and so the Earth doesn't rotate. And it's a commonsensical argument. It makes sense to a certain degree, but this is not. Well, I'll get there. The point is that this, according to geocentrists and flat earthers, does not happen, and so the Earth doesn't spin. I'm gonna just demonstrate the point that they make. So imagine this is London here and New York on the other side of the Earth. Now, obviously, London and New York are not on the other side of the globe. They're not on the equator, anything like that. This is just an illustration. So it's not trying to make their argument look stupid. And in London here, there's an airplane. And this airplane wants to get to New York. Now, first of all of these 3 points will be, oh, sorry, let's just turn off the airplane for a while. Right, so all of these points will be moving at the same speed on the rotating model, and then the airplane wants to get to New York, so it speeds up, right? Like this. And you can see New York is traveling away from the airplane, and once the airplane reaches its destination, it stops. I forgot to stop it, but that's okay. We'll just stop it here and move it back to New York. Now, New York was moving away from the airplane, and so it took longer to reach it than it would have gone traveling the other way. So we'll do that. One, and we'll do it the other way. So there we go. And you can see London is moving towards the airplane and so on. Now, this is an argument that makes no sense if you go by modern science. So the argument that is made by flat earthers and geocentrists is not gonna debunk anything, because this is not the model that modern science teaches. I hope you understand this, that you don't have to accept modern science, you don't have to accept physics, you don't have to accept gravity and all that, but if you are going to debunk it, then you have to actually debunk something that is being taught, something that is actually true by the rules of the physics you are trying to debunk. Because modern science or modern physics has a perfect explanation for this. And this is that, well, first of all, velocity, that is speed, is not something that actually makes any sense in itself. It's meaningless. It's a meaningless concept unless you look at it in relation to other things. You see the airplane is actually above ground, in case you were wondering. We're going to move London and New York pretty close together for this, because I'm going to make them run at the speed of the Earth for this. And this is roughly the speed of the Earth, our Earth, well, the heliocentric model Earth. Okay, and the airplane is moving the other way, so here we go. Now this is quick, velocity speaking. I'll get back to this later in the video actually, but if these points were on the equator, they would be moving, I think 1,000 miles per hour is what they say. I don't know miles very much, but you know, but zooming out, you see that it's not very quick. It's once every day. That's not the point right now, but I want to show you how this works. So the airplane, right now the airplane is in London. It's landed, okay? And then it wants to move forward. And so we speed it up. And there you go. You can see it's using its engines to thrust forward at a great pace. And this makes sense. You know, it moves quicker than the rotation of the Earth. And so it catches up to New York. And now it's in New York. So it's in New York. And now it wants to fly back. Now oops, where did I end up now? There we go. The way the argument goes, as I showed you last time, the airplane should now, you know, if they want to, they could just stop moving. And London will catch up to it. But that isn't how this works, because you need a force to stop moving like that. So the airplane is moving at 1,000 miles per hour already in this direction, together with the Earth, together with the atmosphere, together with everything else. And so it turns its head towards London and it starts flying like this. And it's going slower this way because I can't control speed properly here. It's kind of, I haven't figured it quite out yet. Now, as you can see, it's moving towards London. New York and London, they're all moving together, but the airplane is moving towards London. However, if you were to only look at the airplane, you would see that it's still moving with the rotation of the Earth. So the only thing the airplane is actually doing is moving relative to the motion of the Earth. It doesn't actually move in this direction. It keeps moving in the same direction as the rest of the Earth, but at a slower rate. And so London catches up with the airplane. Now to London and to New York and to the people on the airplane, it looks as though the airplane starts out here and travels in this direction. But to us, you know, who's seeing the whole thing from a motionless perspective, the airplane is still moving in this direction. And so this is how it works on the heliocentric model. Now, as I said, you know, you don't have to accept these rules. You can try to debunk them. You can try to make videos telling people how gravity doesn't work or stuff like that. I think you're wrong, frankly. But the point is that if you want to debunk these things, you have to actually debunk what people are teaching. And this is not what science teaches. If you think this is what science teaches, not what I just showed you, but what I showed you originally, then I can understand that it doesn't make any sense to you, because it would be stupid to believe that the airplane can just stand still and do nothing and London will catch up to him. It's like saying that you're standing on the Earth, and since London is moving so quickly towards you, you should be able to just jump down and let London catch up to you. And that's not how this model works. So I just wanted to make that point. Others have made points about this before, like Minute Physics has a really good, short, nice explanation of this. They do it much better than I do. I just felt like making this thing here and address it, especially towards people who don't think the Earth rotates. Now I had a second point, and that is to do with the speed of the rotation. So we'll just turn off the airplane and... Ooh, who do I side with, London or New York? I guess since I'm European, I'll side with London here. So London is moving, okay? And if you're really close, then you can see it's moving pretty fast, right? It's moving at, I think they said 1,000 miles per hour. I don't know about that, but you know, it's really fast. And so another argument that, oh, London just whizzed past us. There she is. Another argument that I frequently see made by people who don't think the Earth is rotating is that we should feel it, right? If it's moving so quickly, we should feel either the movement or something else. And we don't, so that's proof that the Earth doesn't rotate. Now this is also false, and people have made this point many times, and it still seems not to quite stick. And the reason for this is the Earth isn't spinning very quickly. Look at this. This is once every 24 hours. This is really, really slow. Now imagine this was a wheel. The car would barely be moving. Imagine this was, you know, a tennis ball with water on it. Water wouldn't be thrown off the Earth because it's moving really, really slowly. It's rotating very slowly. And this is how this works. Okay? This is how, at least this is how modern physics expects it to work. A tennis ball rotates several times a second, and water is thrown off it if it's wet. And this is the comparison a lot of people make. They say, oh, look at this tennis ball, water is flying off from it. Why isn't this happening to the Earth? It's spinning real crazy fast. But it's not spinning crazy fast. That's the whole point. It's spinning really slowly, or rotating rather. Well, to be exact, it's rotating at 0.0001 rotations per second, I think. Maybe not. Maybe it's 0.00. Yeah, it's 0.00001 rotations per second. It's just this thing is a bit wonky. I haven't quite figured out this program yet. The point being, this wouldn't generate enough force to fly people off the sides. And I've also seen the point made that if the Earth is spinning around the equator, then people should weigh less on the poles. And I don't want to sound denigrating, but in very typical flat earther fashion, they then claim that, you know, people never address this point. People never say that people should be weighing less on the North Pole. But the thing is, they do. You know, I think if you go to the North Pole, you'll weigh slightly less. This is in physics textbooks. This is on the internet. It's not a secret. You might not accept it. You might say, "Oh, yeah, they're just saying that because they want their globe to work." You know, that could be a valid point. That's not what I'm saying. What I'm saying is, this is physics as we know it. This is how physicists expect the world to work, and this is what they teach people. And I had one more point about this rotation speed. Yeah, I watched a stream with Jeranism and some other people, a podcast, Globebusters, and they made this point that it's the edge velocity that really counts when you spin. And I wanted to make an analogy to make you understand that no, this is not the case. And that's an analogy that you can understand, because if you drive a car, right, you're driving at 20 miles per hour. I'm not very good with miles, but I'll use miles for your sake. You're driving at 20 miles per hour, and then you take a U-turn, or you take two U-turns. The first U-turn, you drive at 20 miles per hour, and you drive it, it's a 20-meter wide U-turn, right? You can imagine that it's not going to be very, it's not going to have a very real effect on your body or the car. You're not going to feel it very much. It's going to be, you know, a gentle turn. Then imagine you're driving the exact same velocity, but this time you're driving a U-turn of 2 meters, right? what's going to happen? You're going to feel a much stronger force. So it's not the edge velocity. You know, that the U-turn you just took, that's tracing a circle, right? And you are the edge velocity on that circle. But that's not how this works. It's the rotations per time. So London, you're not on the equator, but if you were, you'd be moving, you'd be whizzing past. Whoa, there you went. There you are. And it's really quick. Oh! But as you zoom out, you realize the Earth is big and it's not rotating very quickly. So thank you for watching this video. Again, I'd much rather recommend, you know, watching Minute Physics or something like that. They got this stuff much better than I do. But yeah, this is my point. And you know, the Earth might be flat, it might be stationary. But if you want to argue that, don't please stop using this as an argument, because it's not. Right? Thank you very much.